Hey, how's it going everyone? Welcome to the stream. Once again running quite a bit later, but life happens. Alright, so last stream I was not feeling super well, a little under the weather. To be honest, looking back, I think I probably shouldn't have been streaming because I was not quite there, but anyway. I did work on a couple of optimizations. I did a bunch of tests since then, and I've noticed that these optimizations made little difference. Well, the only one that did make a difference was this really small one, which was just not to hash instructions if I wasn't running my sync protocol. So that one actually is significant. But the other ones I did for addressing replacing my ON lookup for device by address in memory bus with an O1 lookup. So this one here didn't really make much of a difference. So I'm just going to keep this in a branch. And then also the coalescing lines didn't seem to make much of a diff. So I'm going to keep those in a branch as well, and just come back to them later. Oh yeah. Well, enjoy your Valentine's, Lisp Gamer. But yeah, so, that's where you see intuition doesn't always help. I thought these things would make a big difference. Well, I mean, we saw this one on the profile. The coalescing lines I thought would help. I thought I saw it, but it seemed to have had no difference. So, but in truth, on this machine, I don't have much of a problem at runtime. I know a lot of the overhead comes from my debugger. So as I said, eventually I'm gonna, change the code so that we don't pay the cost of having a debugger in there. For the final game or the final emulator. And as for so one thing I did is I ran this on my laptop, which actually is a better computer in terms of CPU and all that than this machine, but has a worse graphics card because it's like a onboard graphics card. And there I really see like the hit that I have from making the calls to the OpenGL driver. So stuff like, I noticed that, for instance, I run it at about 30 frames per second, but if I disable the glow, like if I run this, if I disable glow, it like runs at about 60. And this doesn't compile. Oh, accidentally deleted that. Yeah, so there's definitely a hit there. Hey Blue Dragon, how's it going, man? Gonna do some drawing tonight? So yeah, like this enable blur thing, you can see even here, it has quite a dramatic effect on frame rate. So I'm at 178 or so, and if I disable it, I'm at 377, 400, right? That's cool, Blue Dragon. So yeah, definitely the blur does have a cost, and at one point I'll look into if there's any way to reduce that cost. But for now, I'm running at a decent frame rate even while I'm on stream. So I'm not going to get like too worked up about it. So what I decided I'm going to work on tonight is I'm going to revisit the code for the VIA. So this code here, the VIA, which is the versatile interface adapter. So this is basically the chip that is like the gateway to all the peripherals that are attached in the Vectrex. So like it's used to control the rendering, like the graphics, the audio, the joystick, the timers, like everything's basically attached to this thing. So I spent quite a bit of time getting this to work initially, and I just want to go in here and kind of like clean up this code a little bit and start to get back into the groove of refamiliarizing myself with this code so that we can continue to go over how it should be working, because I'm pretty sure like the bugs that I have left are all related to some poor implementations of some of the functionality in there. A great example is this analog no center thing, where I have a bunch of games that don't work due to the input not returning that there is no analog left or right. There's something wrong with that, and that comes directly from this code. So yeah, so I'm gonna focus a little bit on that tonight. one thing I would like to do is I'd like to replace these hard-coded values for the register numbers, or like I guess the register index or whatever you want to call it, with actual values. So one thought, of course, is to stick them all into an enum, but I'm not sure I want to do it that way just yet. I'm thinking, because I have these namespaces for each one, and one thought I had was maybe I want to do something like, you know, introduce a constant here and maybe call it reg index or something. And maybe I'll have like something like that. And the idea would be like here, otherwise, maybe it would be useful to have it in an enum, because if I ever have to index into anything, I'd have that, you know? No, I'm not sure. Let's see, what would that look like? Replace all that with a comma at the end. Okay. That's weird. All right. Let's make these all capitalized. So this would be port B. This will just read so much better, right? Where am I at now? Interrupt flag, interrupt flag, right? Interrupt enable. (0xF) is port A without handshake. Okay. Port A, no handshake. Just to give it a name. Oh yes, that's true. Have to use the old namespace enum trick. Thing is, I would use an enum class, except that then I can't actually use them as indices like I want to do, so without actually putting a cast, which sucks. Okay, so this should still work. And then I'll do the write function. Alright, so let's do the next function. this should still work. Okay, looking good. So now this code is actually a lot more legible than it used to be. Why are these public again? Yeah, I'll fix that after. Okay, so let's commit this. So via add enum of register names. Oh, not on a branch. Yeah, that might actually help. You know what? I'm going to no, okay, it's okay. All right. So it looks like I only needed lines to be public. I don't know why I had all the rest in there. I guess I wasn't paying attention when I first implemented this. I've been thinking about this like lines vector and what I want to do with it. I don't really like obviously what I'm doing now, making it public, and then I have in here under render, all I'm doing is I'm grabbing the display and calling draw lines on it. not sure what I want to do here. I feel like this is a problem at a bit of a higher level in terms of like the way I've structured my emulator and what it is that I want from it. There's always been something that bothers me about my design. Specifically, it's the how I have this. So I have the STL engine. So this I'm happy with, but when we run the STL engine, it's here. So we call update here, and then I call render. So like these two calls, it just feels like update is fine. I need to give a chance to the emulator to do its update. But like I feel like the result of the update needs to be the data that the engine needs to render, right? Because all I do in render is I just grab I just call draw lines on the display. And this class too, this display class, isn't all that useful. It even has a function I never call on it, and it just has this one function, draw lines, that takes a vector of lines, and then this function is kind of hacky because it just copies the lines into this global variable. So there's like so much wrong here, you know? And I feel like maybe what I want is more like this update function, its job would be to return this array of lines that needs to be rendered. And then internally, I can pass that data to my GL render scene here directly. And get rid of this render function and get rid of the display altogether. And if I did that, then I wouldn't even have to copy anything. I could just have this one, like let's say like a piece of data, this vector of lines could be part of, say, some render context or something that I would pass in to update, which the VIA would write to, let's say, somehow. And then that would just be used to render from. Let me see, it would be something like, basically we would add this output parameter. for now, let's say, just to keep the code the way it is, we copy out of mlines, and I'll just copy this here. And I'll remove this stuff here. Then in STL engine, we pass in this we'll pass in the render context, I suppose. Because I noticed that in the CPP file we do include the engine client here. So we go to render scene. So this guy comes in. And then in here where we have the GM score lines, so everywhere we have GM score lines, I think we can just, we can just replace it. With render context dot lines. This function is going to disappear. As well as this one. In fact, we can just make it disappear right now. What's the problem? Oh, right. I cannot make it disappear because it's... okay, let's go to the base class because it is pure, but we don't need it, so we'll just remove render, so we're not calling it anywhere, anyway. Okay, so everything looks like it's still working. So let's fast forward through here. Alright, cool. So now, delete that, delete in main, you can get rid of this. We can get rid of display altogether, which makes me happy. Now, this is good. Now, still this part bothers me, but it's getting better. Ideally, this render context would be passed down to the via, but I don't think I can do that cleanly. So maybe what I'll do here what should I do? I was thinking about how do I want to try to move the memory out of there? Thinking about all kinds of things, like, so this is basically one frame, right? Update. So one thing we could do is say, tell the via, okay, we're about to begin a frame, in which case it could clear its internal lines, and then at the end of the frame get back its lines. Or we can have like a call that says, give me your lines and clear what you have. We can move. Does moving help us here? Because obviously here we're copying. But even if I move that, do I end up really saving? Because then the vector from which we move will then get allocated again next frame. So I don't think we save all that much. Okay. something like maybe get and clear lines. See, this is why this bothers me. This just looks gross, you know? Oh yes, I wanted to not clear them when paused, which is what these shenanigans are about here. Alright, you know what? This just means we need two functions. Alright. Not amazing, but we got rid of our public data member. We can always refactor this later. Okay, who wants display here? No, over here. Don't care about display anymore. So, I think this is better. We cleaned up a little bit. We don't have an extra draw render scene function anymore. We use update to get our result for rendering. I think this is good. We got rid of our display class. We don't have this hack anymore in the GL render side to copy into a global variable, which is nice. So I have a lot of global variables here, but that's just because I'm hiding the implementation details. So eventually I'll probably make this a proper class and all that, so that's no big deal. All right, let's get this committed. Just a little bit of refactoring. Okay. I'll say refactor, get rid of, so we got rid of display and have iEngine client update return data in a render context for drawing, for rendering, or just whatever, for in a render context. Gonna get rid of all this now. I was keeping those around because I didn't have names for all my registers, but now that I do, don't really need them anymore. It's too bad that Clang format doesn't align these. I wonder if there's an option for that in Clang format. Maybe. What is this again? Analog state mask. Update cached input state. So when we start our update, we copy. I want to look at this because we know that we have an issue with the analog, right? I'm just curious what it is that I'm doing. So we pass the input actually all the way down into the via. That's interesting. I say that's interesting because that means that the via is aware of input. So actually is aware of engine client. So technically we could go as far as passing in the render context as a modifiable value into here as well. Maybe we'll do that. Like if we pass the render context into this guy, we wrote directly into here. What's the problem here? Oh. Shouldn't be const. Okay. So this is interesting. So now we could get rid of this lines altogether. And that means if we go back to main, now there's the issue of clearing lines. We could get rid of this. We just do an update, and then back in our SDL engine, here we know we've gotten a render context with some lines, and here is where we want to do the clearing. Don't clear lines when paused. So what I like about this is actually I'm technically copying less now, right? Because I have only one vector that I populate and clear, so we have no more copying of a line buffer. It just travels through the entire emulator. Not that it seems to make any difference. But, you know, on more restricted hardware, that would make a difference. Stage this. Now I'll throw this in. Pass the render context all the way down to the via and get rid of its internal lines buffer. I'll be right back. All right. So. So yeah, I wanted to just take a quick look at the stuff related to analog. Try to remind myself how I took care of this. So I have this M joystick analog state, which is basically a cache. Same thing for the joystick button state, and what we do is we just read it from input. So basically what it means is that when we're not moving, the analog state should say we are, say, in the center. And then this is something that gets read through port B what we do is, oh yes, this is the whole comparator thing. So just to show what the problem is again, let's say we take one of these games, like say pole position, or maybe I'll take Solar Quest. Which one would be easier? Okay, let's try pole position. Okay, so the problem in this game is I'm going to be not pressing left nor right, but our car will be turned in one direction once the race starts. Also, we have a bunch of read from unmapped ranger, which is kind of annoying, but 4, 3, 2, 1, and boom. I'm apparently facing left. If I press right, I'm facing right. But if I let go, I'm facing left. So therein lies a problem, right? So let's see if we can somewhat debug this problem. So if we have this here, so here we have a read on port B. Yeah, this is related to the value in port A. Port A. Right, so usually when you want to do this thing, you load up port A, you write to port A the value that you want to compare against, and then you let the comparator run when you read port B to see if the bit got set. And if I recall, port A is a signed value, so it should be something like, you know, like I think it's like 128 or something like that. I need to refresh my memory on this. It's been a little while. No, so I won't be in here. Let's see. Maybe my notes? Did I take some notes about this? Oh yeah, I think one of the tricks I used to understand this was looking at the source code from Mindstorm. But yeah, I had a great doc somewhere that explained this stuff. It was one of these programming docs. Okay, so nothing about input here. No, so internal doesn't talk about it. Oh, maybe it was this one. Inputs? No? Searching again for joystick through everything. Okay, nothing important there. About the FAQ. Okay, this is not super interesting. Oh yeah, joy analog. This might be useful. Alright, this is the high level. Joy analog. Enable mux, select pot. Output 0 to D over A. Disable mux, delay, and end up with B equals 80. Branch of analog pot. F240, which is here. Test the comparator. Check if the bit is set on port B. Bit A. So this is a delay. Why did they do this again? We want to wait some number of cycles from 60 to 80. check the analog flag and branch if analog. I wonder if this should be less than or equals to. I am not finding though the docs that I thought would explain this better. No, and now it faces the other way. Yeah, definitely not getting. I think I'm not implementing this correctly at all. Oh yeah, I read this already. So it is bit 5. That's what this refers to here. Test comparator, and we check if port B has that bit set, which would mean what? It would mean that the value that's in port A is less than the joystick analog state. So let's say port A is 0 and our analog state is 0 because we're not moving. This would not set the comparator. Now we'd branch if not equal, which would be the case. Try next bit position. LSRB. Just what is LSR again? Logical shift. Oh, logical shift. Okay. So we do a logical shift right on B. What does that mean? We would write we would do a write to B. Of the same value, shift it to the right. Okay. Okay, so we initialized B with a bit with B equals 80. Okay, I'm going to try just debugging this a little bit. supposed to. I'm gonna try and load my symbols from this file. And F1, F5. I should be getting my symbols here. Let's see here. What? F1, F5. Okay, so decrement C823. Load the first pot. So X. Load to X was C81F. And then we do a load A. We dereference X and we increment it. So then A should have 1, okay. Branch if not equal. So we did branch. Enable mux and select pot. Store A, clear output 0 to DA. So we should have done that. Clear 01. So that's clearing register A. This is setting 1 and B. This is clearing A on the VIA. And then we decrement 0, which means taking the value in B. Thanks for the follow, local root. So does this make sense that we have 80 here, or we had 81? Given that when we did a store A into 00, that wrote a 1 there. So how do we end up with 81? Means bit, top bit was set. Why is that? Ramp disabled. Okay, fine. Now we decrement, which means that the 1 that we set here became 0. So that's the disabling of the mux. Okay, right. And we have this delay, so this is going to go on for about 20 shots here. until we reach F216. So let's say, how to do this again? Step, continue, until. We should run until F216. Okay, here we are. Yeah, thanks, man. First time? Okay, so check analog flags. We load into A the value at C823, which is what we did here. So that has FF in it. So what does FF mean here? Branch if analog pot. Branch if minus. Okay, so we're checking if it's a negative value, so it looks like that's what it implies, which means we should be going to F240. And sure enough, we're at F240. Oh, nice. C++ 17 fan. That's cool. And assembly, of course. Yeah, it's pretty fun. This is I'm going through my own disassembly here for my emulator. My debugger here, trying to understand why my analog implementation isn't doing the right thing. So any game right now that reads the analog stick on the Vectrex, so I have like a racing game that checks, you know, the analog values to know how much to turn the car. So there are a few games like that, and none of them are working right. So there's something definitely wrong with the way I'm implementing the code for handling these kind of analog reads. Okay, so we load this mask into A, and then we're gonna increment port B to re-enable the mux. So we should see 81. What? Take care, Local Root. Thanks for hanging out, man. Okay, so bit A, what's going on here? F240. Okay, so we said, all right, so we're at F240 now. Okay, yes, here we are. So we loaded 20 into A, and then we are doing a bit A against via port B, right. So we want to check if the comparator bit is set, which it is not. So 0 set, yeah. So if we branch not equal, we should go to F24C. Is that right? We're at F246. Branch if not equal. Oh no, sorry, that's right. It is equal. That makes sense? Wait. Load A20. Compare the value in A against port B. So the bit's not set. So not equal is when 0 is unset. Okay, right. Does this make sense? Okay, right. Okay, so basically we want to go lower if we saw that the bit was set, but in this case it wasn't. So what do we do here? We transfer B to A. Transfer B to A. Why do we do that? Then what's this? EOR A. EOR A? What's that again? Logical exclusive OR. What are we looking for? Transfer B. So B is the flag state of transfer B to A exclusively or the value in A against what's in via port A. And then see, I don't understand what this code is supposed to mean. Exclusively or the value in register A, which is the one that was in B, with what we have in port A, which is D001. And then where does it store the value when we do this? Back in register A. Yeah, the register gets the result. So we bitwise exclusive OR 80 against 0. So we want to toggle all those bits. So this ends up doing nothing. Okay. Store A back into port A. What is this trying to do? Logical shift right B. See this here, this is wrong. Pretty sure this is probably the bug. The fact that here, I think this code is expecting the top bit not to be set in B. think that's it. I think this top bit shouldn't be set, and we should end up with 0, and then we'd end up storing 0 as a result. But we have this top bit set, so that's our problem here. There's an assumption that when this code gets called, let me go see here. Ramp disabled. Stale code warning. Thanks for the follow, Dompin 2010. Oh, thanks, man. Yeah, definitely pouring through some assembly. 6809. The chip in the Vectrex. So yeah, I'm wondering about this. Thanks, man. Appreciate it. It's a cool project. The Vectrex is a very cool machine. You should totally look it up. It's a failed console from like 1982-83, but it failed not because it wasn't a viable project, but because of the video game crash of the era. So it just kind of like bad timing, because it was a very cool console. I don't feel like my logic for the ramp disabled is incorrect. Yeah, rough times indeed. I mean, we don't know for sure if it would have survived had the crash not happened, but I think it was yeah, I don't know. Anyway, I had one. My uncle bought me one when I was a kid. I still have it. I just need to pull it out again. Yeah, so I'm pretty sure this is the problem, and I'm not sure. Like, the ramp should be disabled when we're checking for input. Like, as a test, what I could try is when we read port B, where are we here? So here we are reading, and we want to read port B. So what if we just forced the result not to set the top bit? Or just to be even more clear. Whoa. That does not look right. That's interesting. Why would we care whether the ramp bit is set? Do we care? I guess font rendering cares. It's gonna look at the ramp. Let me just see though. Okay, no, so it still does the same thing. Wait a minute. Still have the same value here. Why is that? Check for accuracy threshold. 0. Right, that's the most accurate, okay. Okay, so no, I think I got mixed up before. I was thinking of that we were shifting a value out of the register B of the VIA, but no, this is just register B of the CPU, of course. We're shifting right. This is reducing the threshold for accuracy reasons. So we end up jumping back here and we say store B -5, x. Transfer B to A. Where are we now? F23C. Okay. Go back if not finished. Transfer B to A. Transfer B to A. Okay, so B is 40, right? Now it gets 40 into A. So that's going to be our use for our comparator.
Now I smash with DK and M. Super Smash Brother. Yeah, we going crazy. Super Smash System. Either you is a man or you is a baby.
Okay, so actually, it's actually port A that has an 80. That's weird. Let me go see. Why does it have an 80 there? Oh no, because we stored it in there. Okay, no, that's normal.
Stop what you're doing. Stop the Pikachu and I'm here to hit y'all with an electric boogaloo. The girls say I'm shooting. Of course they would know. Cause they got faster balls and I put them in show. Real y'all. You ain't no contender. Get your ass thunderclapped into a Pokemon Center. Pika P, I'm the one you can't catch. Run along, kid, you need the gym bag. Super Smash Brother. Yeah, we going crazy. Super Smash Brother. Either you is a man or you is a baby. Super Smash Brother. Either way. My Falcon punchline leave you with stitches, bitches. Bet you get a Falcon kick out of this shit.
All these motherfuckers acting like a ain't gon' shoot. Cause I got a pet monkey and a tie-dye suit. It ain't just a tie-dye suit. This shit is herbal. What do you mean only got tobacco in my cig? This shit is herbal. Cats are battling geeking out like Steve Urkel. I'ma smack the block off Game & Watch. I'ma choke him till he's purple. What I gotta go through to show you that the shit is real. Red exclamation mark on my head. You don't deal, motherfucker. I'ma kill him when I see him. Always crying, Zelda don't ever wanna be with him.
He's 20.
A man like me, the action king, baby.
Transfer B to A, or A, store A,
Want it, you got it. Come and get it, player. We
or
win
A
it.
20,
Gotta do is say it, baby. Come on.
branch not equal.
Really want. Oops, supposed to be stealth shit. I'm making too much noise.
Ladies and gentlemen, this is your captain rapping. Who be burning up tracks like a fresh combatant. Trying to challenge the Falcon for the top of the pile. Dude, the king of evils even jocking my style. How you show me your moves when I think I've seen them before. But try to test me, you get
What?
an SG0. Cause I take on the Mutant City just to zip up the gap. I come in first, then second on the victory lap. Oh,
Ness is in the spot. Ready to go and get your matter up. Anything that hits a home run. Matter dodge out of the way. You think you okay? You're terrible.
All right. Yeah.
BK, I'll watch you decay. You feeling me? There's no getting away. BK thunder, make it rain. You ain't never gonna be the same. When you witness the usage of all my power drains, had to make them earthbound. Cause you know I'm really on it. And I bring a lot of flair. Let's BK honest.
So now this compare. This branch not equals should go to F23A, should not go to F23A. And there we go. So now we've made it to F252. So read the DA value from port A. And we read 80 back. 24A. 24A. Store A. What value in A came from? What was already in port A? We start by clearing it, and then we should be branch output and then to port B. Here we store B into there, which means we put 40. No, we don't make it this far. No. We actually branch it to 40 here. We load A with that. When does port A get? I guess it's this one here. Shouldn't that have been 0 here? So yeah, my question right now is why does port A have a value of 80 in it ever? To begin with. Seeing as we actually write a 0 to it. Right, where is it again? Clear output here, F20D. So here we wrote 0 to it. So let's see. There's 0, and then here we end up doing it. So I wonder about this here. We have an 80 in there. Why do we have 80 in here? Load into A, the value at C823. Load into A20. Transfer B to A. Okay, and B got its value from where? This is where the 80 comes from. It comes from B. Let's follow B here. So we've been incrementing B. Alright, we saw that. We wanted to increment B until we reached 80. We were starting at 60 up until 80, so this was like a delay. Then we purposely transfer 80 from B to A. Then we do an exclusive OR into A with whatever value is currently on the DAC, which is super weird. Which has no effect. I wonder what this line is for. What's the purpose of this EORA? and end up with B equals 80. So we really did want B to have 80. We want to set that top bit, which I guess is the idea, but then transfer it into A. Okay, so here's where we increase until we reach 80. Go to 40. We want to test comparator. Like, is this weird? Is this what we want? Okay, I guess we want both bits on. No, we want this. Okay, so I guess that's the idea behind this OR over here. This is just going to keep turning on bits like this, right? Back to 80 here. C0. Transfer B to A. Not following this logic. Unfortunately, if somebody knows what this, how this joystick code is supposed to work, I understand that it's doing some kind of like successive approximation. I just don't understand what it means. And what it is that we expect to be happening here. It says the return value will be equal to 0 if it's centered. So that's the thing. Right now, I do expect that when we're done this routine, the value in port A on the DAC should be 0, but we end up with a value of 80. So somewhere in here, like this code is obviously correct. It's there's some interaction with the via that I'm not respecting, it seems. We're like in this loop right here. And I just need to understand what this loop is about. Is exactly the same. Here's a listing F23A. Yeah, it's exactly the same. F23A. Okay, it's exactly the same. It seems when we're done, A still has 80, and it should have 0. So I think we saw that port A should have a 0 in it as well when we start, right? We clear it here. And port B, what does port B have? think I had like 80 or 81 or something. I think it's 80. Let's check. F23A. F24C. F23A. We never made it to F23A? Ah. Okay, not the first time. That's right, we jumped to LF240. So yeah, it should be 80. Let me see here. Let's do this. Start here, and let's see when we actually hit F240. And let's do a read. How do we do this again? Hey, what's up, Will the Ninja? So how can you get started with game developing or coding? So you've done no programming whatsoever? You're saying you want to start, but you don't know how. Well, I mean, there are lots of ways to start learning programming. You know, there's the more conventional approaches, obviously. Like you can try to take some courses. There's lots of like great online courses that you can start with, even free ones. There's one pretty good course, I think it's on Coursera. Do you know Coursera? They have a good one on Python that I could recommend. Is it this one here? Oh, I don't know which one it was that I tried. And maybe it wasn't Coursera. What was it again? I think maybe it was Udemy. Python Bootcamp. You know, a little bit, but not much. Well, anyway, I don't remember where it was. I'd seen this. There was a nice course where it was like free and it was interactive, and you know, you have like these problems and you get to write your Python code, and you kind of like learn bit by bit, and it teaches you the basic concepts of programming. And Python's a friendly language to start learning programming in. It's become kind of like the de facto programming, like de facto language for teaching programming in universities. And I think it's a good choice. It's a lot friendlier, say, than learning C++ as your first programming language, or Java or anything like that. I would definitely not recommend starting with those. So yeah, like, you know, or get yourself a book. That's another way. Or if you're more someone who needs the kind of formality of a classroom, definitely look into taking a class somewhere. There's so many places now that'll teach you programming. You know, that's the kind of thing I would look at. I mean, I assume you're asking about game development because that's where you'd like to go, and that, you know, that's cool. That's why I started programming. I wanted to make games as well, but I had to first learn how to actually code, you know. In my case, which was a while ago, I learned from a book on Pascal. So that was really like the first official programming language I learned. And then after that, I was able to learn C and start making games. So I did a lot of reading. Basically, at the time, I was just reading books and trying things. I had some mentors, some people online. There was one guy in particular who really taught me a lot about making games back in the day. And yeah, so it's a lot of practice, a lot of reading, and finding today with resources we have today, it's way easier than when I started. But like I said, you know, the internet, you have lots of free courses, videos, tutorials, interactive tutorials. So check any of those things out, and yeah, ask questions, and don't give up. It's an interesting journey, that's for sure. Do I make money with doing this, as in this project? Or do you mean programming in general? Because I work as a developer, so yes, I make money developing, but this project in particular is not paid. It's just a hobby. It's a hobby project. Okay, you meant programming in general. Yeah, definitely make money programming. That's my career. I work for a game company, a private game company where I live, and yeah, I've been working for, what is it now? Since 2004? Yeah, so about 14 years. Or going on 14 years that I've been in the games industry. Programming a bit longer than that, about 16, 17 years. But I've been programming, like paid to program, I should say. I want to take computer science. Will I need it? Will it be helpful? You want to take computer science? You want to go to university and study computer science? So, I mean, I studied computer science, and I do think it's helpful. Some people will disagree. It depends on where you are in your life and you know what you want to invest into. But I do believe that there is value in a university degree, especially if you're at that age, you're around 20 years old, and you're looking to start your career, and you'd like to have a degree under your belt. It certainly opens doors. It's true that in programming you can get a job without a degree, but I have found that it's more like you'd have to work harder to get your foot in the door at most companies. And it's kind of like if you have the degree, that's like, you know, at least that base is covered. Now, as for what you learn, I do think there's a lot of value as well to actually taking a computer science degree. You know, different schools, different universities are offer better programs than others, but I think there's a lot you can learn. The formalism of computer science it's an important base for understanding computing, understanding algorithms and algorithmic complexity. These are all things that are very useful, and they are useful in your day-to-day. Now, can you learn them without going to university? Sure. And lots of people do, and lots of people have been very, very successful. But I'd say, like, if you want to put, you know, if you want to stack the cards on your side, it's a pretty safe bet that getting a computer science degree or computer engineering or, you know, any one of those is a good idea. That's my opinion. F20B. So here's where we clear A. Oh, right. Yeah, it's tough at 18. You know, you're expected to choose, you know, your entire future. At 18, it is difficult. But if you are interested in computers, if you're into computers already, and you know, you don't mind sitting in front of one and poring over these kinds of, you know, lines of text and thinking and solving these kinds of problems, it's definitely an interesting career. I personally love programming. I think it's extremely rewarding, a lot of immediate gratification, and it also happens to be a pretty good career in terms of job market, right? These days, there's always jobs for programmers, so, you know, if you're into it, definitely a decent career. Actually, looks like they're both equal to 0 when we reach here. Is that always true? Oh, wait a minute. Disable 3, okay. Enable 3, and then print the values. Yeah, they are equal to 0, 0. Oh, thanks a lot for the follow, Will the Ninja. And glad to be of any help. And there it is. Thank you. And then we said that here, if we say info reg, B is 80, here A is FF. Why would that be here? Well, I guess we don't really care because we're just about to put 20 into it, right? Right. So I said B is equal to 80. Oh, okay, so this is a bit of a lie here. Okay. Start the first time. First iteration. For subsequent iterations. Set to 20 at F240. We check port B, branch to go lower. So what about that? We're checking if the comparator is set. The comparator is not set. The comparator gets set if the value in A is less than the joystick value we're testing against, which will never be true if I'm not pressing anything. So that makes sense that we continue. Now we transfer B to A, which puts 80 into A, and then we do this exclusive OR of A. against what's in port A, which is 20. I don't know, it's 80 now because we just transferred B into there. I find this really strange. Port A. Port A is D001. It's got 0 in there. So we're going to do an exclusive OR of 80 against 0, which will just return 80. Right? Yeah. Is that right? Exclusive OR is supposed to right. So yeah, in our case, it's exclusive OR of a 1-bit set here against 0, so we just get back that 1, and all the rest just remain zeros because it's all 0, 0. So what is it we're hoping to achieve there? It's about turning on a bit if it got set in one place. This has to do again with the shifting. And now we take the result and we store it back into port A, because that's what we're going to use to compare against in the comparator. Like, I think what we're trying to do is we're trying to increase slowly the resolution of values. B becomes 40. So we do a logical shift right. We compare. We transfer B to A, so now A became 40. And then here, this OR A here. Now we're up here. This is the part I'm a bit unsure about. What is this OR A about? If any bit is set, we turn it on. So yeah, so this comes back to what I was saying earlier, that we want to set both the top, like bit 8, bit 7, bit 6, which should give us C. Sure. And we store that back into port A. C0, sure. Now we load A with the comparator to test what's in port B, right? So now we test and we get 0 back from port B, right? Branch if not equal to F24C. Transfer B to A again. Transfer B to A, transfer B to A. So that there's a symmetry here, right? One where we do an OR and one where we do an exclusive OR. now we're about to do an exclusive OR. So we're exclusive ORing the value that was in A, which is 40, against C0. So that turns off the bit that we just set in the previous one. So we go back to 80. Is that what we want? Why do we do this? So we put back 80 in here? Okay, so we're like undoing what we did before. And now we shift B back, transfer B into A, so now A has 20. Now when we OR A, we end up with 101. Which seems odd. Why would we be testing? Oh, okay, I think this is negative. Oh, I guess that's what it is. It's a signed value. So what we want to do is keep this bit on, turn this one off, turn this one on now. So we want to turn on the bit that we're testing against. Okay. I guess after A, it'll be 90. Right. And then finally 81. So let's see if this is true. Do the comparator. Now we transfer B back into A to effectively undo, so we're back to 80, right. Let's set the test bit. Brings it back to, I guess. I guess it depends if we want to be checking negatives or positive. I think that's what this is about. it's 80 for now because we're looking for negatives, but if we were looking for positive, it wouldn't be 80. Test for left, or is it down? I don't know. So now we're testing 1, 0. And there's our 90. Comes back. Now we put that in there. Or A, we get 88. 84, 82, 81. 84, 82, 81. 80. So now B becomes 0. So actually, it kind of makes sense the way it ends up working. But that's it. This is a signed value that's equal to minus 128. So we end up returning minus 128 here. See here? The fact that we return 80 as a signed value, that's minus 128. C. Compare, check for accuracy threshold, then branch if not equal to LF23A, otherwise we say read the DAC value and then load that into B. Which reads 80. We branch to LF236, and then we store the AD results. So that's weird. What is it we expect? Oh wait a minute, I was reading this here. So maybe it's not true what I said about having to return 0. Yeah, it does check the sign of the value. I don't see how this can work. So what I see is that necessarily this code will start off with b equals 80. When we want to check analog, we go here. And what we proceed to do is we transfer 80 into A. And then this will do nothing the first time. And basically that bit, that top bit in A, will just always be set. And so basically we're starting at minus 128, then we're going to test minus 64, then minus 96, minus 112, then minus 120, minus 124. Does that make sense? Doesn't make that much sense, does it? Oh no, I guess it does. We're checking to see
Play them at their own game.
minus 64.
First thing is to get Joey running again.
Minus 96. I don't know. It's really weird. I just don't understand this function. I don't understand what it's trying to do. Even though I've analyzed this code, even though I see what's happening, I don't understand what it's purporting to do. Let me think. The comparator will be set. We're looking to see if the comparator bit ever gets set. Now that's going to happen if the value that we store in A, was it less than the value that's in B? On the via side, let's see here. The value in A is less than the joystick value we set comparator. So what we're doing is we're trying, we start with minus 128 and we compare that against. But see that doesn't make a lot of sense. We wouldn't start with the largest negative value, now would we? Oh no, maybe we would. Okay, so if we think about the range as minus 128 to 128, and we're holding our joystick all the way left, and we're asking for a resolution up until 0.
Welcome back, Joey.
Is this the best shell you could find?
Yeah, but this doesn't make sense. This shifting of bits here. Yeah, this doesn't make sense. Wait a minute. Oh no, okay. Yeah, alright, that makes sense. A is 40 here, and this is C, right? So then it just ends up setting 1 bit. Okay, I don't know. It's late, and I'm not any closer, so I'm gonna stop here, sleep on it, and maybe it'll come to me. Or if any of you who are watching this afterwards see what I'm missing, well, hit me up, let me know. If not, I'll be back at this on Wednesday. So, thanks for watching, and see you in a couple.